Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Accelerating AI-Powered Vision Solutions for Next-Gen Enterprises, brought to you by Tech Online, eInfoChips, Aero, and broadcast by Aspen Core. I'm Colleen Heckman, and I'll be your moderator today. We have just a few brief announcements before we begin. First, the slides will advance automatically throughout the event. We recommend you disable your pop-up blockers. You may also download a copy of the slides by clicking on the green folder icon located at the bottom of your screen. You can participate in the Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window and then click the Submit button. At the end of the webinar, we will ask you to complete our feedback form. Your feedback will provide us with valuable information on how we can improve future events. You can also launch the survey at any time simply by clicking on the red survey button at the bottom of your screen. If you're experiencing any technical problems, please type your issue into the Q&A text area and we'll be glad to offer one-on-one assistance. And now, onto the presentation, Accelerating AI-Powered Vision Solutions for Next-Gen Enterprises. Discussing today's topic are Devel Vasa, Solution Architecture, eInfoChips, and Aero Company. Devel has a strong background in security and surveillance, consumer electronics, and semiconductors, and more than 20 years experience in providing solutions to leading security and surveillance, CE, and semiconductor companies by leveraging the latest technologies and building a center of excellence. And joining Devel today is Arohe Desai, Associate Director, Product Marketing for Platform Partnerships and Semiconductor Practice at eInfoChips and Aero Company. For over 12 years, she's been responsible for launching modules and development kits based on the latest platforms to accelerate development of innovative products across industry verticals. It's with great pleasure I now hand things over to Arohe to begin.
Thank you, Colin. Hello, everyone. I hope you all are doing well. A warm welcome to all of you joining us from different parts of the world. Thank you for taking the time to be here with us today. My name is Arohi Desai and I am an Associate Director of Product Marketing, leading strategic initiatives at eInfoTips. Along with me, I have Dhaval Vasa, Director of Solutions and Subject Matter Expert for AI Edge Solutions. Before we start the session, I did like to provide a brief overview of the agenda for this webinar. In this webinar, we will cover latest trends and applications of computer vision technology, typical challenges and solutions, key platforms and technologies that are required to develop these solutions, and last but not the least, we would also like to introduce our new initiative called Edge Labs and iCree, our product portfolio of modules and development kits targeted for next-gen intelligent products. I hope you enjoy the session. A computer vision solution refers to the use of cameras and computer vision algorithms to enable machines to perceive and understand their surroundings. This technology combines the capabilities of cameras, image processing, and artificial intelligence to analyze visual data and make intelligent decisions based on that. A typical computer vision solution comprises of 6 building blocks: high-resolution camera, image acquisition, image processing, computer algorithms, decision-making, integration, and automation. The high-resolution cameras capture images or videos of the scene or object that needs to be analyzed. These cameras can be integrated into various devices or mounted on robotic systems. The captured images are then fed into the machine vision system for further processing. The images may require processing steps like image enhancement or noise reduction to improve the quality and accuracy of subsequent analysis. The image processing algorithms analyze the images to extract relevant information and features. This step may involve operations like image segmentation, edge detection, object recognition, or feature extraction. Further, going forward, computer vision algorithms such as deep learning or traditional computer vision techniques are further applied to interpret the processed images. These algorithms can detect and classify objects, recognize patterns, measure distances, estimate size, or can perform specific tasks based on the end application requirement. The analyzed visual data is used to make informed decisions or trigger specific actions. For example, in industrial applications, computer vision systems can detect defects in manufacturing processes and signal for corrective actions or automate quality control. These camera-based machine vision solutions are often integrated into larger systems or automated processes. These integrations may involve connecting the machine vision system with other devices such as robotic arms or conveyor belts to enable real-time feedback and control. There has been a significant increase in camera deployment and the amount of visual data generated by them. Today, there are more than 1 billion deployed cameras that capture 30 billion images per second and generate more than 2,500 petabytes of data. Till now, most of this video data was not processed or interpreted for further actions. However, this is changing with the recent advancement in technology. According to a report by Markets and Markets, the global computer vision market size is projected to reach 25.5 billion US dollars by 2026. Several factors have contributed to this growth, mainly adoption of AI technologies across industry, advancement in camera sensors, improvisation in computer vision algorithms, and rapid adoption of smart devices with integrated cameras for different industries. AI/ML and computer vision systems were perceived to be complex with high memory and network bandwidth requirements. Till now, AI techniques were deployed at data centers to perform processor demanding tasks, resulting in slower response. The exponential rise in IoT edge devices has resulted in large amount of data generation on network edge. To ensure real-time quick response and efficient use of network bandwidth, it is important to push AI techniques at the edge. Edge AI is a form of distributed computing where all computations occur outside of the cloud at the edge of the centralized server. This function of edge computing is supported by devices that can capture visual data and perform computations locally on the device closer to the source of data, making that data immediately actionable. In this scenario, only selective data is stored in cloud for data analytics and further insights. However, deploying these technologies to high-volume, cost-sensitive IoT edge devices was limited due to stringent BOM and cost constraints. The launch of low-cost, multi-core, low-power SoCs by leading platform companies has facilitated scaling of AI-enabled edge devices. AI-enabled vision solutions have applications across various industry verticals. These solutions have the potential to enhance productivity, efficiency, and improve accuracy for different enterprises. They are extensively used in security and surveillance domain to analyze video footage in real time, fleet monitoring, and developing intelligent collaboration systems. They have been extensively used for also industrial applications for real-time quality monitoring, factory automation, developing systems for worker safety. Robots without visual perceptions are like blind machines doing repetitive tasks. Thanks to the computer vision systems, they are becoming more intelligent and they can see their surroundings and move accordingly to perform various actions. Even in healthcare domain, these systems are extensively used for remote patient monitoring, diagnostics, and they also are being used for helping in surgical planning as well as real-time assistance during surgical procedures.
Thank you, Arohi, for introducing the topic. I will cover technical aspects associated with AI-powered vision solution for enterprises that have helped the customers. When deploying edge-based AI solution using camera, following are important considerations. Image and video resolutions and associated quality parameters are critical. Image and video processing requirements for given use cases. Computational requirements to be estimated in respect to CPU, GPU, DSP, and AI engine for inferencing and decision making on the edge. And connectivity at interface level as well as connectivity to cloud, web, or mobile application is critical to be budgeted. Let's look at the typical solution workflow. For any edge AI-based solution, typical flow includes capture, process, record, analyze, and sustain. Usually, the capture stage involves image sensor integration, characterization, and associated processing. This is first step to get the right image or a video, which will be processed further by subsequent subsystems. Once the capture process provides good image or a video as input, the process stage consists of post-processing blocks, encoding or transcoding, and streaming such data based on different use cases and application. For example, streaming requirements for broadcasting equipment is different than that of a healthcare, but the latency is a common requirement for both the use cases. Depending on the use case, record stage provides recording, archiving, and on-demand viewing support. Different use cases such as telematics, drones, robotics, healthcare having different needs for recording and archiving, either in form of resolution or compliances to the law for record keeping. Analyze stage is critical in a present context since AI is at the center stage of everything we do. This is where computational needs are important and architecting becomes challenging. Partitioning AI implementation between edge and cloud is critical too. And sustenance stage is to implement orchestration that allows for ease of use, ease of deployment, enhancements, optimizing AI models for additional datasets, etc. Let's deep dive into camera subsystems, which typically comprises of three main elements, popularly also called as subsystems: camera input subsystem, core camera subsystem, and heterogeneous computing subsystem. Camera input subsystem consists of lens and image sensors. Depending on the use case, there can be one or more image sensors used. Robotics application use different type of image sensors, such as RGB, time of flight, LiDAR, etc., for performing sensor fusion. Healthcare equipment meant for personal diagnosis may have one or more types of image sensors to identify anomalies or taking readings. For security and surveillance application, commonly used image sensors are RGB and IR. Core camera subsystem consists of pre-processing, image signal processing, and post-processing prop. These are critical to improving image quality, which will be used by subsequent subsystem for analytics and decision making. We shall have more detail in a subsequent slides. And heterogeneous computing subsystem focuses on computational needs based on target use case. Heavy AI models may need powerful AI engine with inferencing using GPU, DSP, and CPU. When performing face detection for security and surveillance use case, it's important to be able to run such model on either of these computational engine based on system load and computational requirements of the model for better inferencing. Let's understand key consideration for camera input subsystem. Selection of lens and image sensor is heavily dependent on target use cases and product category. Security and surveillance application need higher pixel density and a larger pixel size based on sensors versus typical sensors are found in the cellular phones, which do not have the same need. Similarly, the inspection systems need either line scan or an area scan type sensors that are more appropriate for the use case. Optics typically ensure that the camera captures the object that you are actually interested in, and thus focal length, focus type, aperture, and depth are important consideration in selection of optics. Lighting conditions and dynamic range is to preserve the relative intensity between the brightest detail as compared to the intensity of the darkest detail within the image, and give as much as possible of this information to vision algorithms. The type of target where rolling shutter are used for the use cases that do not involve motion capture, and global shutter are used that involve motion captures. The field of view is dependent on use cases, like the retail analytics, where you can capture a larger data set of people entering or exiting store. Or imagine you have a video conferencing system where you have to get a smaller FOV horizontally and vertically too, depending on the size of the room for which it is meant for. So these are some of the important considerations in selection of lens and image sensors. Core camera subsystem is most critical to get desired image quality for the product. This consists of pre-processing, image signal processor, and post-processing blocks. Image correction and adjustments are carried out in form of lens distortion correction, electronics image stabilization, optical image stabilization, color correction, and effect pixel correction, to name a few. It also helps in carrying out noise reduction, scaling, autofocus, auto white balance, and auto exposure control related tuning. At InfoChips, over a number of years, we have been designing camera drivers and tuning them based on Qualcomm platforms. We offer services in form of camera driver development, porting enhancements for the features needed for the product, or it could be for specific sensor feature enablement. We also support sensor characterization for sensor parameters, lens and color shading compensation, auto exposure and auto white balance related tuning, and related objective and subjective tuning. Over the years, we have been able to tune image sensor modules and image sensors based on OEMs like OmniVision, Sony, Samsung, and onsemi. As part of the tuning parameters, we take care of white balance accuracy, color errors, saturation, contrast and gamma, sharpness, noise reduction, and lens distortion correction, as well as high dynamic ranges. These are some of the hardware platforms that we have already worked on based on Qualcomm processors, and we continue to enhance these portfolios based on Qualcomm SoCs. At InfoChips, we have invested in camera tuning lab with equipment having light booths, filters, light equipment, light meters, and most importantly, different charts that are used for camera tuning. Using these equipment, our teams carry out objective and subjective tuning and configure image signal processor as part of Qualcomm platforms. For measuring image quality related KPI, we use IMA-Test software, which is used across industry as one of the benchmarks. In subsequent slide, we will showcase how we have carried out some of the objective and subjective tuning. With this chart, we are showing some of the camera objective tuning work that our teams have carried out based on Qualcomm platform. As you can see on the first half of the chart, you see different lighting conditions as well as different light intensities like the A50 lux, CWF 200 lux, and D65 500 lux as different lighting conditions prior to the tuning. And the bottom part shows after objective tuning what sort of results our team have been able to achieve. As you can see, with different lights and different light intensity, our teams are able to get more consistent image, which is the objective of this tuning process. Like previous chart, this focuses on the subjective tuning outdoor. As you can see, 6 different images which give you a very different type of objects being shown to it, different type of colors, different light intensities. This enables us to tune it for real life situations. Imagine you have a dash cam which does not give you the right set of colors when the sun faces it. This is when you need to carry out some of the subjective tuning for an outdoor environment, which provides you different color intensity, different light intensity, and much wider range. And this is where tuning with HDR becomes critical. This chart shows some of the sample images based on the HDR and lens distortion correction related tuning that our teams carried out on Qualcomm platforms. The top half images, as you can see from the left to the right, show the default image which was captured prior to any sort of tuning for the LDC and HDR. The second image on the top showcases how the HDR has an impact. If you look at carefully, in the default image, you do not see the exit sign shown correctly. Versus when you look at the HDR tuning which is carried out, when you start reading the exit sign more appropriately. And then the biggest challenge with the first and the second image on the top is that the image is looking bended, and that's why you need to carry out a lens distortion correction. So once you carry out a lens distortion correction as well as HDR, the image, what you see on the third on the top, is what is the final output that you see after the tuning. An equivalent is shown for the outdoor environment, where you see different sky condition from the left to the right when you go from default to all the way LDC plus HDR based tuning. Last up is heterogeneous computing, which is focus area now due to AI, and how AI is implemented on the edge. Key consideration for design are selection of CPU core, GPU, DSP, and associated KPIs are floating point processing, timing latency, etc., since they impact the output. AI engines are commonly measured in TOPS, which is not the most popular method of measuring performance, but highly advertised. Most important metric for AI engine performance is inference per second or inference latency. Qualcomm AI Stack is a unified AI software portfolio for mobile, automotive, XR, compute, IoT, and cloud platforms. It is designed to help developers optimize and deploy AI models quickly by supporting AI frameworks and runtimes, also developer libraries, system software, and popular operating systems. The Qualcomm AI Stack, from top to the bottom, supports popular AI frameworks such as TensorFlow, PyTorch, ONNX, and runtimes include TensorFlow Lite, TensorFlow Lite Micro, ONNX runtime. In addition, it includes inferencing SDKs like Qualcomm Neural Processing SDK. The developer libraries and services support latest programming languages, virtual platforms based on open source QEMU, and compilers include LLVM and TVM. At a lower level, the system software includes basic RTOS, system interfaces, and drivers. We also have a rich variety of OS support spanning across different product lines. Support includes Android, Windows, Linux, QNX, and deploy monitoring infrastructure like Kubernetes, Dockers, etc. These combinations of OS support will enable advanced features, for example, the digital twin for automotive use cases that enable real-time data on both the device and the cloud. Qualcomm AI Engine Direct will now scale across every AI accelerator inside broad range of products. OEMs and developers now have the ability to develop and optimize AI models using Qualcomm AI Stack once and then move the same model across different Qualcomm Technologies products and tiers for a truly develop once, deploy anywhere model. Let's look at how we have used Qualcomm AI Stack in actual use case. Here we are showing a use case of semantic segmentation. Segmentation as a pixel-wise grouping is used in scene understanding in various applications. Road scene segmentation is one such use case. We have trained and created inference pipeline for few of the best performing models like BiceNet, KNet, UNet on datasets like Cityscape, which consist of diverse urban street scenes across 50 different cities. And also we have used IDD and IDD Lite datasets. IDD is Indian road data that includes unorganized traffic scenarios, and IDD Lite is a lightweight version of the same. The performance metrics with the best performing combination is listed in the table with model size. We have used mean intersection over union as a performance metrics to compare these models. KNet is a special image segmentation network that employs an asymmetric decoder to recover precise spatial detail of prediction maps. BiceNet V2 is a backbone consists of two branches, namely the details branch and the semantic branch. The details branch is responsible for extracting spatial information, which is a low-level information, while the semantic branch is designed to capture high-level semantics. Then it is followed by an aggregation layer and a segmentation head. UNet is a network whose architecture was modified and extended to work with fewer training images and yield more precise segmentation. It has three major components: encoder, decoder, and skip connections. Here we are showing a demonstration of semantic segmentation for Indian subcontinent, where you will see segmentations carried out for roads with green color, with sky having blue color, and vegetation with pink color, to name a few. This was carried out by leveraging Qualcomm technologies in hardware and software. Snapdragon Neural Processing Engine provides the ability for users to perform custom neural network operations that may not be inherently supported by the runtime engine in the form of UDO. These could be operations defined in popular training frameworks such as TensorFlow, or custom operations that are built based on framework extensions but not available in Snapdragon Neural Processing Engine SDK. They can be natively executed on any of the supported hardware accelerator for which they are implemented. We have created UDOs of operations like mix pooling that was not inherently supported. We also created multiple UDOs for GPU runtime using OpenCL and compared the performance gain for the same operation when running on CPU runtime. For example, sigmoid UDO's computation time sees 5 to 6 time gain on GPU runtime as compared to CPU, as reported in the table. UDOs created here includes mix pooling, max pooling, depth to space, and sigmoid. These were tested using Acri QCS 80-50 based development kit by eInfochips. One additional example we want to discuss today is about facial recognition. Face recognition technology is gaining a lot of attention across different applications. We have demonstrated technology at eInfochips to perform human face recognition in video images. Multitask Cascaded Convolutional Networks (MTCNN) framework was developed for face detection and face alignment. The framework adopted three-stage learning through CNN-based architecture. In the first stage, it uses a shallow CNN to quickly produce candidate windows. In the second stage, it refines the proposed candidates' windows through a more complex CNN. In the final stage, further refinements are done through the CNN to get the facial landmark positions. The batches of extracted faces with label data passes it to FaceNet architecture. FaceNet is another neural network-based system that uses deep learning algorithms to recognize faces. It is also using CNN model with embedded concept to map facial features into Euclidean space where distances directly correspond to a measure of a face similarity. This space is then used to compare faces and recognize whether they belong to the same person or not. Extreme Value Machine, EVM, is also integrated with FaceNet to identify the unknown faces. Those are used neither in training nor in testing. When discussing technology, it's hard not to mention artificial intelligence. It has become omnipresent and a key pillar. Edge AI overcomes latency, power, and privacy issues, making edge devices learn, adapt, evolve, and think for themselves. However, developing superior edge and AI solution is increasingly challenging due to lack of expertise, limited access to high-performance edge and AI chipsets, and stringent power requirements. Infochips, Arrow Electronics, and Qualcomm Technologies have expanded their strategic collaboration with the establishment of Edge Labs, a center of excellence. This will help customers accelerate the development of connected intelligent edge devices. Edge Labs has access to the state-of-the-art infrastructure, including hardware, image quality tuning, and wireless testing labs to help with design, development, and prototyping. With Acri portfolio of off-the-shelf system-on modules and development kits, Infochips accelerates and de-risks design cycles for Edge AI solutions across robotics, cameras, displays, audio-video collaboration, industrial automation, healthcare, security, and other connected Edge AI applications. We have subject matter experts, experienced team on digital transformation solution from edge to cloud, infrastructure, and partner ecosystem in place. With the Acri portfolio of off-the-shelf system-on-module and development kits, Infochips accelerates and de-risk design cycle for Edge AI solution. As part of the roadmap, we have system-on-module and development kits covering entry, mid, high, and premier tier of Qualcomm IoT processors. We have announced QCS 4290, 2290, and QRB 4210, 2210 based SOM and DevKit, which will be available starting June 2023. We will be launching QCS 6490, 5430, and QCS 8550 based system-on-module and development kits by Q4 of this year and Q1 of next year, respectively. To conclude, we covered Vision AI adoption across industries and related technologies. Developing such highly integrated, complex solution requires sophisticated engineering. That concludes our presentation, and I will hand it back to Colleen for question and answers. Thank you.
Well, thank you, Arohe and Deval, for an excellent presentation. We are now moving on to our question and answer portion of the event. As a reminder, to participate in our Q&A, just type your question into the text box located to the right of the presentation window and click the Q&A icon at the bottom if you'd like, and then just hit the submit button. We'll try to get to as many questions as we can today with the time we have left. If we do not get to your individual questions, someone will get back to you after the program is over. So, okay, folks, so it looks like we've got several questions coming in, so let's get started. First question, what kind of tool and infrastructure is required for image tuning lab?
Great question, Colin. This is Babu Basha. I think in terms of establishing such an image tuning lab requires a room or a lab environment which comprises of the light booth, different types of lights, light meters, as well as most important are the charts, depending on what type of product for which you are doing tuning. That's going to be one of the most important elements of the tuning. And then you need to have qualitative measurement-related tools like the EMA test that we talked about during the presentation today is one of the ways in which you can measure the output of the image tuning that you carry out and benchmark it again. So these are like minimum set of tools that you need. And from a subjective tuning standpoint, you definitely need a wider set of color, wider set of lighting conditions, an environment where you can expose the camera to very different conditions.
Yes, thank you very much. Thank you for that. All right, moving on to the next question. What are the typical pressure points or roadblocks in development of customized vision AI solution for a particular application?
Well, in terms of pressure points, the biggest ones are how do you partition AI between the edge and the cloud, or if your application is primarily edge dominated, then how do you make sure that the AI model will fit into the computational resource that you have for you to be able to do inferencing at a speed or based on the use case. So I feel that the pressure points are definitely in terms of partitioning AI. The second most important is what are your starting points for those AI models? Are these open source models which may not be giving you the kind of accuracy, so you have to work on training those. Important other element in training is what data set you get. Those are some of the major pressure points today from an AI implementation perspective on the edge.
Excellent, thank you. It looks like we've got one more question here for you. And what are the key factors considered in platform image sensing selection for different verticals and applications?
Great question. I think we did touch upon this during the webinar today on the camera input subsystem. One of the most important factors is what sort of application or a use case this product is meant for. So if you are designing something which is outdoor, requires a lot of light to be provided, then you definitely need a larger pixel sizes. That's definitely one. Depending on the type of application, like inspection systems, they have specialized line and area scan related cameras that you need to pick because those are more important from that use case perspective. But then you have optics configuration, you have lighting, and the product will be used indoor, outdoor. What sort of lighting? Is it a extremely low light? Basically, light sensitivity drives it. And then you have rolling shutter, global shutter. So if you're designing something which is like a high motion sensitive, then definitely you need to have the global shutter and so on. And then you have a field of view which defines what sort of image you capture horizontally or vertically. And then there are additional mechanisms of synchronizing these cameras, which is equally important. So these are some of the important considerations.
Excellent. Yes, thank you. Excellent for that. Thank you. That's definitely all the questions we have. So thank you so much. I want to thank Deval and Rohe for a fantastic presentation and Q&A. And to our audience, for more information related to today's program, please look at any of the resource links and documents in your resource folder, the green resource folder located at the bottom of your screen. And within 24 hours, you will receive a personalized follow-up email and details with a link to today's presentation on demand. So thank you for attending today's webinar, Accelerating AI-Powered Vision Solutions for Next-Gen Enterprises, brought to you by Tech Online, eInfoChips, and Arrow. This webinar is copyright 2023 by AspenCore. The presentation materials are owned by or copyright by Tech Online, eInfoChips, and Arrow, and the individual speakers are solely responsible for their content and opinion. On behalf of our guests, eInfoChips, and Arrow, I'm Colleen Heckman, and thank you for your time today, and we hope you have a wonderful day. Thank you.